Hello everybody. In this video, I will help you with your final exam preparation. I will discuss the 2024 Gauteng Prelim Paper 2 Question 5. 5.1, simplify, and then they give you that horrible thing to a single trigonometric term. Now, our aim is to make all the angles acute angles by using reduction formula. On the first one, sin squared 180 plus x. Now, this is the 180 minus theta quadrant, and the third quadrant is the 180 plus quadrant. So we can reduce the sin squared 180 plus x to sin x, but in this quadrant, the third quadrant, tan is positive and sin is negative. That is why this will be a negative. And since it's sin squared, you put the minus sin x inside a bracket and you square it. The second term, we have sin negative x. Now the rule is the sin of a negative angle becomes minus the sin of the positive angle over. On this one at the bottom, we have minus sin 90 degrees plus x. Now this one is the 90 minus theta quadrant, and the second quadrant is the 90 plus theta quadrant. And when we use 90 plus and minus, or 270 plus and minus, the name changes to the co-function. So that one will change to minus cos x. I just want to show you this minus is this minus, and the 90 plus quadrant, this is sin's quadrant. This is why there isn't an additional minus there. And then the other one times tan x. Now tan, we all know, is the quotient identity, and we can write it as sin x over cos x, and there's your minus 1. In the next step, now we will square this negative and into the sin x, so it becomes positive sin squared x times the minus sin x, and on the denominator we can say cos x and cos x will cancel, and we're left with minus sin x minus 1. Then, where's the minus 1? There it is. Now we can say sin squared x, and then what I did was I said a minus divided by a minus is a plus. Sin x and sin x will cancel, and then this minus 1 is this minus 1. Then we end with sin squared x minus 1. From grade 11, we have the squares identity, where we can say sin squared x plus cos squared x is equal to 1. And then when you take the 1 across, it becomes negative, and when you take the cos squared x, it becomes negative. So sin squared x minus 1 is equal to negative cos squared x, and that's what you want. 5.2, given cos a minus b is equal to cos a cos b plus sin a sin b. So that one we call the compound angle formula for cos a minus b. Number 1, use the above identity to show that sin a plus b is equal to that. So what we will do is we will start with sin a plus b. Then sin a plus b is exactly the same as cos 90 minus a plus b. 90 minus whatever this angle was. Then in the next step, and remember it's the 90 plus and minus is a co-function, so the name sin will change to the function cos. Now in the next step, I will multiply in the negative, and it becomes cos in a bracket 90 minus a minus b. And then what I did was I grouped those two together. So now can you see I have the one that was given, this one. There's a cos a minus b. So here this whole 90 degrees minus a is this angle, minus b is that angle. So we can expand this one by using that formula. So we can say It's cos 90 minus a cos b plus sin 90 minus a sin b. And now we will deal with each one individually, where we will say cos 90 minus a is the same as sin a, the reduction formula. Remember, the name changes because it's a cofunction. And the cos b will write with, and then sin 90 degrees minus a will become cos a, and there's your sin b. 5.2. Without a calculator, simplify the following. Now the aim here is to write all your angles as acute angles. So on cos 420, what we do is we simply subtract a revolution. So you subtract 360 and then you end with cos 60. Now I just want to show you that in fact you used this reduction formula to get to cos 60, but what you do is you subtract 360 because 360 plus 60 is equal to 420. So that one reduces to cos 60, and 60 is an acute angle. On the second one, cos 15, that one is already acute, so you just rewrite it. And then on this one, sin 300. Now that one, let's do it here. We will use the reduction formula sin 360 minus 60. And remember, this is the 360 minus quadrant. So therefore, this is cos's quadrant. So sin will be negative. So that one reduces to negative sin 60. So there's your negative sin 60. I put it inside a bracket. And then on the last one, there's a cos 105. Again, we need to write it as an acute angle. So we will use cos 90 plus 15. And remember, this is the 90 plus quadrant. It's sin's quadrant. And then it's a 90 plus, so the name will change to the cofunction. So therefore, it becomes sin 15. In fact, it becomes negative sin 15. There you go. Then, in the next step, what I did was, now let's see. Do you agree? This is a minus times a minus is a plus. So the whole let's call it an expression, will be positive there. And then this is the compound angle for cos, because there's your pattern. Cos, cos, sin, sin, 60, 15. And when there's a plus there inside your bracket, there's a minus. So 60 minus 15 is cos 45. And cos 45 is equal to root 2 over 2. 5.3, given, and then they give you that identity, and they say show that that horrible thing is equal to cos 2x over cos squared x. Now, my advice to you is start on the side that looks complicated. Now, that is definitely the left-hand side. There you go. So the first thing that I will do here is I'm going to multiply in the tan squared x, and it becomes tan squared x over tan squared x minus tan squared x. Then you can say tan squared x and tan squared x will cancel each other out, and you're left with 1 minus tan squared x. So now the only way that you can go further is by writing tan as sin squared over cos squared x. Now that thing in algebra will look like this: 1 over x, 1 minus x over y. So you will find the LCD, and that means the 1 changes into a y over y minus x over y, and then when you put it together, you end with y minus x over y. So when you go back to our trig expression, then the 1, we can rewrite that as cos squared x over cos squared x, and then the whole thing can become cos squared x minus sin squared x over cos squared x. And then on the numerator, this thing is equal to the double angle for cos 2x over cos squared x, and that's your final answer. 5.3.2, for which value or values of x in the interval x is an element 0 to 180 is that thing undefined. Now the rule is whenever there's a tan, then you don't even think about it. You say at x is equal to 90 degrees because that's where tan has its asymptote. 5.4. Determine the general solution of the equation cos 2x is equal to cos x. So, there's your sum. Now, the first thing that I will deal with is, can you see, this is a double angle for cos 2x. Now, we have three options, which option to choose. I chose the one that contains the cos, since I have a cos on this side. Then in the next step, I'll let the cos x walk across, it becomes negative. And then that one is in fact a quadratic equation that you can factorize. So if you have a look at the right hand side, this is that very same thing in algebra. And you can factorize by saying it's bracket 2x plus 1 bracket x minus 1. So that's the algebra. So in trigonometry, that thing factorizes to bracket 2 cos x plus 1 bracket cos x minus 1 equals 0. And now you deal with each one individually. So therefore cos x is minus a half, or cos x is equal to 1. Then what we can do is we can work out the reference angle here. So we can say shift cos a half is equal to 60 degrees. And a reference angle is always positive. Now what about this minus? That minus will tell you in which quadrant you're working. That says where is cos negative. Cos is negative in the second quadrant, where we can say x is 180 minus 60 degrees plus k times 360, k element z, and then that thing simplifies to 120. I said 180 minus the reference angle is 120 plus k times 360, k element z. And where is cos also negative? Cos is negative, and this is the third quadrant. So we will write x is 180 plus, and this is the reference angle, plus k times 360, k element z, and that simplifies to x is 240 degrees plus k times 360, k element z. And then don't forget about this little one. We still have cos x is equal to 1. So that will happen at x is equal to k times 360. This means every 360 degrees, cos's value, y value, will be 1. Guys, there's a message from my dog, Carosi Valentino. .5. It is given that sin theta is equal to a half. Calculate the numeric value of sin 3 theta without the use of a calculator. So now you'll say, ma'am, what is this 3 theta? We know about double angles and compound angles, but not triple angles. So your job is to rewrite the sin 3 theta into a compound angle consisting of 2 theta plus theta, because 2 theta plus theta is 3 theta. And then this was a sin, so this is a sin. Now you're dealing with the compound angle for sin. So that thing we can expand and write it as sin 2 theta cos theta plus cos 2 theta sin theta. Then we have double angles. So on the first one, sin 2 theta, this one, there's only one option anyway. We can write it as 2 sin theta cos theta, and then this cos theta is this one. And then on the other side of the plus, we have a cos 2 theta. You have 3 options there. So now let the rest of the sum guide you. So on this side there's a sin and a cos. So I use the one that has the sin. It really doesn't matter. And I wrote cos 2 theta as 1 minus 2 sin squared theta, and then there's this sin theta. So now in the next step I'm going to multiply in this cos theta, and I end with 2 sin theta cos squared theta plus, and then on this side I multiplied in the sin theta. So I end with sin theta minus 2 sin cubed theta. Then everything is in terms of sin now. So therefore what I did was this cos squared theta was in the way. So I rewrote cos squared theta as 1 minus sin squared theta. Now be careful, this is not a double angle. This is grade 11 where you have sin squared theta plus cos squared theta is equal to 1. The square is identity, and then you can write cos squared theta as 1 minus sin squared theta. So it's the identity, it's not a double angle. And there's your sin theta, and there's your minus 2 sin cubed theta. There it is. Now in this step I'm going to multiply in this 2 sin theta, and I end with 2 sin theta minus 2 sin cubed theta plus sin theta minus 2 sin cubed theta, and then I add like terms. So there's a 2 sin theta plus a sin theta is 3 sin theta, and then minus 2 sin cubed theta minus another 2 sin cubed theta is minus 4 sin cubed theta. And then now when it feels as if you're stuck, remember it was given on top there that sin theta is equal to a half. So in sin theta's place you substitute a half. And then when you slot that into your calculator, you end with 1. All that work and the answer is 1. Thank you for watching my video. In the left hand corner, if you click on that video, it will take you to the next video of this 2024 prelim paper. On the right hand side, you will find the 2 playlists for grade 11 and grade 12 trigonometry if you need to go back to those.